Let's look at an application of quadratic equations involving right triangles and the Pythagorean theorem. So let me first remind you about the Pythagorean theorem. It states something like this. If you have a right triangle is a triangle with a right angle or a 90-degree angle, like this. And let's call this side leg 1, and I'll explain all this in a moment. Leg 2. Now, the side opposite the right angle, wherever the right angle is located, is called the hypotenuse. The other two sides that are not opposite the right angle are just called legs. It doesn't matter which one you label as leg 1 or leg 2. But what follows is this interesting equation that Pythagoras came up with, or the Pythagoreans came up with, is that if you take the length of leg 1 and square it, and add it to the length of leg 2 and square it, then you interestingly enough get the length of the hypotenuse squared. So it seems natural that the Pythagorean theorem could result in quadratic equations, because notice that everything in this equation is squared. Okay, let's see if we can apply this new idea. So here's an example. We have the hypotenuse of a right triangle's length is 13 centimeters. The longer leg is 7 meters longer than the shorter leg. Determine the length of the legs. So let's draw a right triangle here and start labeling things. We know the hypotenuse is 13 centimeters. The longer leg, so we'll of course assume that's the vertical leg, is 7 centimeters longer than the shorter leg. So let's call the shorter leg x, so x represents the length of the short leg. Then the long leg has to be that short leg plus 7, because it's 7 more than the shorter leg. So now our Pythagorean theorem tells us that if I take this leg squared plus this leg squared, I get 13 squared. So let's set that up. We end up with x squared plus x plus 7 squared equals 13 squared. And lo and behold, we get a quadratic equation. Let's get rid of all these parentheses so that we can see what we're dealing with. X squared is easy, that's just x squared, you don't need the parentheses there. X plus 7 squared, though, is x plus 7 times x plus 7. Be very careful in doing this. So if you were to multiply all this out, you would get x squared plus 14x plus 49 equals 13 squared, which is 169. Now maybe we'll combine all our terms and get 0 on one side. So x squared plus x squared is 2x squared plus 14x. And then if I subtract 169 from 49, I get negative 120 equals 0. And now solve this quadratic equation using whatever technique you like. This one in particular, factors, so you can try that. It's a trinomial. Factor the 2 out first, of course. But when you do, you should end up with x equals negative 12 or x equals 5. Well, x represents the length of the short leg, so there's no possible way that x could be negative 12. So the short leg has to be 5 centimeters, and the long leg has to be 7 more than that, right? So 5 plus 7 is 12 centimeters. And there we go, we've determined the lengths of the legs of this triangle. If you check it with the Pythagorean theorem, you'll see that 5 squared plus 12 squared equals the 13 squared. I also want to point out that this negative 12 is not related to this positive 12 that we got. The positive 12 simply came from